Hey, welcome to this week's math lesson on transformations, where we're going to review some grade 5 learning and apply some new knowledge that we have gotten in grade 6 to help us understand transformations even better. So let's get started. With our learning goals for this week, I can perform and describe a single transformation of a 2D shape in a coordinate grid. Lots of vocabulary this week for our language goals, so I'm going to pop the camera away and the toolbars so we can see them all. I can talk about shapes using words like rectangle, parallelogram, rhombus, trapezoid, quadrilateral, and triangle. I can talk about movement using words like coordinate grid, transformation, translation, rotation, point of rotation, reflection, and line of reflection. Let's review what we have learned in prior years about transformations. Now, you've been learning about transformations since at least grade 4, but you probably talked about them a lot using words like slide, turn, and flip. Hopefully last year in grade 5, you used the correct math vocabulary terms a little bit more, so you're prepared to use them exclusively in grade 6, because that is my expectation, that we will only use these 3 words: translations, rotations, and reflections. Translations are our slides, rotations are the turns, and reflections are the flips. But no more using the words slide, turn, and flip. We're only going to use these terms: translation, rotation, and reflection. Got it? Good. Which transformation is going to move that quadrilateral ABCD to its image, NMPQ? If you like, you can pause the video for a minute and think about it, try and visualize it in your head, and decide what kind of transformation it might be. Did you get it? What answer did you get? Did you choose reflection? If you did, give yourself a pat on the back because you got it right. But it's really easy to think that this might be a rotation. So I want to try it out and see why that doesn't work. I'm going to try rotating this shape around a point of rotation that is about at 5.5 on the x-axis and 9.5 on the y-axis. And I'm going to vanish the camera so that we can watch this transformation take place. So we're going to start by shading in the original shape, tracing it out so that we can rotate it. If we rotate it a quarter turn or do a 90-degree rotation about that point of reflection that is indicated by the red dot, we get this image. Well, that's not what we're looking for. So let's try another quarter turn. That brings us to a total of a half turn or a 180-degree rotation. And we still haven't managed to match up with the green shape, which is the image MNPQ. Let's try one more turn. So if we add one more quarter turn, we've done a full 3/4 turn or 270-degree rotation, and still no luck. So we can cross off reflection. That was definitely, we can cross off rotation. Sorry, that was definitely not a rotation. None of those images was correct. So that leaves us with reflection. I just want to point out how we know this is not a translation. So when we do a translation, the shape must stay in the same orientation. And these two shapes are not in the same orientation. And the way we can tell is if we take one of the line segments and just extend it like this, we can see that this line segment, CD, points in a vertical direction, going that way. And then if we take the same line segment on the image, that would be PQ here, because it's the longest line segment. I know it's the same one. and we extend it that way, well, we see that it's actually perpendicular. So they're definitely not in the same orientation. If they were in the same orientation, then this line should be extending in the exact same direction, but it's not. It's perpendicular. So that's how we can tell that this transformation is not a translation. And we just tried a rotation and that didn't work. So we know we're dealing with a reflection here. So let's try it out and see what happens if we reflect this shape. Let's try reflecting it in a vertical line that passes through a point between 5 and 6 on the x-axis. So you can see that line of reflection there in red and our tracing of the original quadrilateral ABCD in pink. Now, if we reflect it, we get this image, which doesn't look quite right. So let's try something else. This time, let's try a horizontal line of reflection. This line of reflection passes through the x-axis between 9 and 10. That reflection image isn't quite right either. Let's take a look at both of our reflection images together and see if it helps us figure it out. So now we have both lines of reflection and both reflection images. We see them together. We can see that what we need is something that's in between those two lines of reflection. Let's figure this out. These dashed lines represent the two lines of reflection we just tried that aren't quite right. And I notice that these lines make a right angle where they intersect. I want to try a line of reflection that's in the middle of these two lines. So I'm going to draw a line that bisects the right angle. And bisect means to cut it in half. So I know that a right angle measures 90 degrees, and half of that is 45 degrees. So I will draw a new line of reflection just like this. It cuts that 90-degree angle in half exactly and makes a 45-degree angle. So that solid red line is my new line of reflection that I'm going to try. There we go. Now, let's trace the shape and reflect it and move it to its new location. Boom! That's it. We got it. So now that we know what kind of transformation this is, we have a second question to answer about this. What are the coordinates of the vertices of the quadrilateral ABCD and its image MNPQ? Let's write them out. Vertex A, right here, is at 1, 2. That's its coordinates. We can tell by extending down from vertex A and seeing where we intersect the x-axis, and that is at point 1. And then we extend this way to intersect the y-axis, which we do at 2. So that's how we know that our ordered pair, is 1, 2. We always do our x-axis value first and then our y-axis value. Let's try it again in a different color for B. B, we're going to extend down. We're intersecting the x-axis at 1 again, and we extend left and see that we intersect the y-axis at 5. So we have our ordered pair 1, 5. Now let's do point C. We extend down, we intersect the x-axis at 5, and we extend to the left, we intersect the y-axis at 9. So we get the pair 5, 9. And last but not least, vertex D. We're going to extend down to intersect the x-axis. We do so at 0.5, so that's our x-axis value. And we extend over to the y-axis, which we intersect at 2, so that's our y-axis value. And our ordered pair for vertex D is 5, 2. Now we'll repeat the same thing in order to get the ordered pairs or coordinates for the image MNPQ. Point M is at 1014, N is at 1314, P is at 1310, and Q is at 610. Now, did you notice that we skipped a letter? We didn't use the letter O. Do you have any idea why? It's actually really simple. When you write out the letter O, especially capital O, and we always use capitals when we're labeling shapes in geometry, it looks an awful lot like the number 0, which can create some confusion. So to prevent confusion, when we are labeling points or line segments or vertices, we just skip that letter O. We don't use it. So hence quadrilateral MNPQ.